In addition to just solving this problem, let's create a process by which we can solve many different types of Excel-based valuation problems. By using a repeated process, it's going to start with us narrating the story, and then as we do, documenting all assumptions, meaning we're going to put labels in a column and then key data into the second one so that we can use them as variables. So for example, we see in here that we're going to have a graduation date of May 2022. May 2022. And you're going to work at a marketing firm and you will make $2,000 per month as your income. So here's your income after tax because it says 2,000 after tax. I'm going to highlight that. And I like using subscripts so that things have nicer labels on them. So income after tax, $2,000. That means you're getting approximately $32,000 per year in salary. All right, so your income then annually, so the full year, we can pick something like that, highlight it, get it into the format cells, make it subscript. Oops, I made it a superscript. Subscript. Okay, is approximately $32,000 per year because you pay a tax rate, it appears, of 25%. And that looks like includes everything federal, state, and local. You're most worried about paying back your college debt. So you have debt that totals right now $43,298 that you now owe over the next 10 years. All right. So we're going to call that the length of loan, which is 10. And whenever I put down something in a data cell with a label, if possible, you want to give it a label too. So that would be like length of loan in years, because your brain is going to look and start picking up on clues. Like oftentimes when you own debt, you're going to make things like a monthly payment. So I could do things like say there are so number of months per year, and there's 12 of those, so that I could know that like the length of my loan, not just in years, but in months, would be equal to 120 payments. I don't even know if this exact part appears in the solution that I created on the side, but organically, the more that I label, the better off I am, because anything I get down, I can use for formulaic calculations later. Okay, so you're most worried about paying college debt, 43,298, and that you owed over 10 years. Got it. Where there are months per year 12, and you're going to make a monthly payment starting on January 1st, 2023. Fastest Loans quote you a fixed interest rate of 7.35% annually. This is where, too, I'm going to be careful and say something like rate annual. And notice that doing the parentheses gives it the same kind of look as doing the subscript. It's just a matter of preference. Excel is part art and part science. It just must be understandable. So do you understand that my rate annually is 0.0735%? Because I can make that into sign for us and then expand those decimals so that we could even do something like rate, and likely monthly for a rate is going to help us too, because one of the ways that we're going to do the calculation is going to rely on a monthly rate conversion. A monthly rate then would just be the annual rate divided by the number of months in a year, which suggests a per period interest rate of what says 1%. But if I make that larger, it's probably actually a couple numbers behind the decimal there of 0.613% per month. Okay, now that we have everything documented, the third step in the process I always like is to determine what is being solved for. In this case, it's saying what is the amount of the payment you will make in March 2030. What I've done is over here typed up already the 5 variables that we will always be using when we're doing time value of money problems. Those are PV for present value. They are FV for future value. They are PMT, payments, They are interest rate, 50%, and they are number of periods, which is going to dictate some time. Notice I have these three labeled intentionally the same because as we bring up the Excel formulas, we're going to see that there's a need for congruity in how often we make payments, the rate that applies to those payments, and then the number of payments that we will make. So we're going to go ahead and wire in what we know, which is if you get a loan, that would be like somebody giving you right now $43,290. But they would ask you then to pay them back. In this case, over a number of periods, that's 10 years, but your periods occur every month. So it's 120 different periods for which you will pay back the loan. Each period, because this is a loan and not a gift, will be subject to a tax, where that rate is going to be equal to 0.613%. Future value asks if there's an individual amount at the end of this thing, what we would often call like a balloon type payment, whereby you could lower your payments every single period by making one big payment at the end, but there's nothing to indicate that we have that in here. Oops, not payment, in the wrong place. Future value up here. So the question is then, how much are we being asked to pay monthly to pay back this loan? So in Excel, where we're going to go is formulas. From formulas, I'm going to go ahead and find these functions. I'm going to find the financial functions. I'm going to look and see that there are 5 formulas that we will use regularly. There's PV right here. There is FV right here, future value. There's scrolling the wrong way now, PMT right here. There's rate right here. And then there is N per right there. So when we know what is being solved for, in this case, payment, then what we're going to do is use the Excel function. In this Excel function up here, it's going to guide us through it, what it wants. For example, it says rate is the interest rate paid per period. So we know that that's our monthly interest rate. N per is the total number of payments, in this case, 120. PV, it says, is the present value of the total amount of that series is worth right now. The PV, the loan, is right here. The future value would be something in the future, or 0 if omitted. We've got a 0 typed in there. And now we can click OK. And you see we get a calculation that suggests that out of our pockets will be made negative in this case. Negative signifies a cash flow out. We are the payers of the debt. So when we get 43 now, we will pay 510 and 57 every month for 120 months because we borrowed at this interest rate. So question number 1 right here would be, what is the amount of the payment that you will make in March 2030? Why 2030? Because whenever you have a loan and you have a fixed rate and a fixed period, the payments are always going to be the exact same. Okay, what about the second part? Let me go ahead, sorry. Before we finish the second part, let me finish the process. Determine what is being solved for. Next step. When you're doing time value of money problems, you're going to use any of those 5 formulas I showed. When we do other types of problems, there will be other appropriate formulas that we can easily look up and use our favorite sites like Investopedia or Corporate Finance Institute. But there's always some type of formula calculation in here before we can then solve and then interpret what all that means. So right now, what I was finishing with is the interpretation that that loan will be a cash flow out of 51057 every month for 120 months, which is 10 years, or the interest rate that we agreed to make the loan at. Now, you read an article that said your student loan payment should be no more than 20% of your monthly take home pay. So, what is yours? So, it looks like the formula that is being told to us up here is that your monthly percentage, 20%, I'm having a hard time saying, 20% is the max you would want this formula to be equal to. You pay $510 per month in a payment, but you're dividing that by your income that you make on an after tax basis. So in our case, if we went ahead and calculated that, notice I'm going to switch the minus sign. Why? I'm not doing a time value of money formula. I'm just doing a basic formula. I don't want my number to start as a negative when I speak in algebra terms, only when I speak in Excel time value of money function terms. So I switch that sign so I can divide then a positive 510 by my income on an after tax basis that I make every month. And that suggests that 26% is the amount of my loan that it consumes as a percentage of the after-tax income I make every month. So at least according to this article, I would be in trouble because I'm paying more for student debt than I should be given my income. So I have two choices. Either try to lower this, that'll get me to the 20%, or go out and get a better job. And then maybe that way I could be more in line with what the readings suggest.